My name is John Gallagher, and I'm an assistant professor in environmental systems modelling in Trinity College, Dublin. I sit within the Department of Civil Structural and Environmental Engineering, and today I want to give you an engineer's perspective on our role in combating the climate crisis. So, in our present day, and more importantly going forward, what does an engineer offer in terms of addressing this global challenge? Well, engineering in the field that I work in civil engineering, is a very important area when addressing how we transition and transform our relationship with energy, with resources, and how we develop a future infrastructure that is cleaner and greener. Whether that's renewable energy technologies, how we treat wastewater, how we build buildings so that they're energy efficient, or how we deliver new forms of transport infrastructure. But perhaps I need to also acknowledge that engineering has perhaps not always solved every single problem. We've actually potentially produced some problems along the way. So it's an evolving field, always trying to improve, and as we move forward, we learn from how we've done things in the past. Whether that's how we have generated energy, how we've used resources in perhaps a less efficient manner than we should, how our infrastructure has perhaps not been as resilient to an ever-changing climate, and also in terms of how we move mobility and how we move around, in that we have contributed to the climate crisis through emissions. My own perspective is linked very much to the type of research that I do, whether that is a range of projects related to water and the water energy nexus, whether that is to do with air pollution or environmental quality, and also our relationship with resources, whether that's plastics or finite resources that we need to use efficiently. And I'm fortunate to be involved in projects at a national and international level that deal with different aspects of that. In a very simple form, just to illustrate the work that I do in terms of research and teaching, and transforming some of that research into teaching content and ensuring our engineers of the future are aware of these challenges and can address them. My approach is through three areas: in measuring, modelling, and mitigation. Illustrate the importance of measuring, quantifying the problem, applying models and simulations and tools to look at future scenarios, and then from that develop informed mitigation techniques. So the first of these four areas that I want to highlight is our relationship with the resources. Engineers play a key role in the design and implementation of buildings, of renewable technologies, and general infrastructure within the built environment. And we need to be aware of the quantities of materials we use and their associated environmental impacts. Designing and developing infrastructure that is circular in nature, in that you can extract that material at the end of its life and reuse it in an effective way. So it's important to embed that in our teaching, but to look at future solutions through our research. That may mean using more materials to make infrastructure more resilient, or perhaps less materials through innovative design. And it's important to get that balance correct. Then in the area of water and the water cycle, the area I work in is supporting the development of engineering technology, innovative technical solutions that can support a more sustainable water cycle. And my role is to examine those technologies to make them more robust and to make them more carbon and resource efficient. That can further enhance the sustainability of the water cycle. It's important to acknowledge that the water cycle, when it comes to drinking water from your tap, to the treatment of your wastewater, that within that cycle there is a key need for energy. So we may assume that renewable technologies are the solution for this. The research that I undertake and the teaching that is linked to that challenges the sustainability of renewable technologies, looking towards their life cycle and trying to identify pathways to allow circularity, as mentioned previously with resources, enhance their performance, and look towards generations or iterations of these technologies, because their contribution to mitigating environmental pollution and to supporting a reverse of our climate crisis is key. But we must do that in a sustainable fashion. And lastly, what's very important to me is addressing the continuing problem that is air pollution and indeed environmental pollution. Excess heat in the built environment, noise pollution and air. And so the model of source receptor pathways is a central focus for me, trying to look at what causes pollution, who is affected by the pollution, and developing mitigation solutions both for today and into the future through green infrastructure or nature-based solutions. Future-proofing is central to this, and future-proofing is central to all of the research areas that I feel are important. When it comes to addressing the climate crisis and my perspective as an engineer in addressing this global challenge, you require multi, cross or transdisciplinarity to achieve that. You need collaboration across all disciplines, because the climate crisis is something that affects us all in different ways, and we need to acknowledge that. And research can play a key role in defining pathways and a roadmap towards that future. But within E3, in terms of teaching our future graduates from the range of programs that we offer, research-led, project-based learning is key. Our students experience what can be applied in terms of understanding the most current research and applying that to problems that society faces. And within that, within the circular economy and my work in that area, that's central to balanced solutions, utilizing resources, energy, water, and protecting ourselves from and reducing pollution. All of these areas are what's key to the ambition and the vision that is creating balanced solutions for a better world. So I hope that gives you a small insight into my work in Trinity College, and thank you for your attention.